Hello, this is Hart Hagen in Louisville, Kentucky, and let's talk about dry lands and desertification, how we degrade our land and how to fix it. I've been a climate reporter for 6 years, and the more time goes on, the more skeptical I am about the mainstream narrative around climate. I was fully inclined to believe it all, and then more as time goes on. Yes, climate change is real, but the people that are feeding us a very simplistic narrative about carbon dioxide don't seem to be really serious about solving the problem. If they were serious about solving the problem, there's a ton of ways we could rapidly cool down our climate, but they're not talking about that. They're only talking about lowering CO2, which will take about a century or more. So in that regard, I prepared this presentation, Drylands and Desertification, and let's talk about it, how we degrade our land and how to fix it. The high points of this talk will be, I have a slide about drylands, another one about desertification, another one about lowering farm expenses, because we can lower our farm expenses and at the same time fix climate change if we care about that. And also, lowering farm expenses will be part of the same package as lowering CO2. Number 4, we'll talk about something called effective rainfall, because that has to do with how much rain is soaking into the ground as opposed to how much falls from the sky. Those are two different things. We will talk about nitrogen fixing bacteria, because we have to understand that in order to have the rain soak into the land. And lastly, not least, we'll talk about the principles of soil health. The great thing about the principles of soil health is that we can implement them wherever we are. Wherever you own or manage or control any amount of land, we can practice the principles of soil health. So let's start with this next slide, drylands. So what are drylands and what's the deal there? The drylands are places where there is a rainy season and a dry season. And the reason they're called drylands is, in some cases they'll get less than 10 inches of rain, but in some cases they get 20 or 30 inches of rain, but it all falls during the rainy season, and then there's a long dry season. We're talking about, large parts of India and Africa are like this. And then the Western United States, a large part of it is like this, except places like Nevada and Arizona get less than 10 inches of rain per year. But dryland is a place where when the rain falls, we have to capture the rain when it does fall, and we have to have a way of doing that. That's what item number 2 is. We have to capture the rainfall. Item number 3, we have to practice the principles of soil health. We have to have soil that is ready to capture the rainfall. So items 3, 4, and 5 are ways to capture the rainfall during the rainy season so that our ground has the rain for green growth during the dry season. Number 4, we have to have vegetation in place. Vegetation varies from place to place, but whether it's trees, whether it's bushes, whether it's herbaceous, wildflowers, whether it's grasses or some combination of those, we need vegetation because vegetation captures rainfall. Soil holds the most rainfall, and vegetation holds a whole lot of rainfall. So we need vegetation. If we want to make the drylands places that are habitable for people and our fellow species, then we need to have good soil and vegetation. Number 5, we might need to do check dams. Like, whenever you have a gully, you're capturing the water so that the rain doesn't flow off of the land. Because a dry land is dry because when it rains, it floods, and when it floods, it all goes into the streams and the rivers and quickly into the ocean, and that's not what we want to happen. We need to capture the rain where it falls. Item number 6, agriculture is a big part of fixing this problem. The title of today's talk is Drylands and Desertification, How We Degrade Our Land and How to Fix It. Agriculture is a big part of that. Agriculture is, by definition, agriculture is something that we do in places where it's habitable, but not yet concreted over. So, agriculture can either degrade the land or restore the land. So we need to understand how to do that. Item number 7, forestry. Forestry is important because a forest is a place where it can either it'll capture the rainfall if the forest is still there. But if you degrade the forest, if you clear cut the forest, then it's no longer a place that can capture rainfall. Item number 8, all of this is important in terms of wildlife management. So most places that are somewhat habitable, I mean places that are not too high or cold or rocky for places to live, these are places that also have wildlife. Wildlife management, as opposed to what? As opposed to, if it's not a farm or a forest, then wildlife management comes into play. And that's important because animals contribute to ecosystems and ecosystems capture the rainfall. Item number 9, design for hydration. Designing for hydration is what we do in the built environment. We can build the environment for hydration or we can build it for drainage. Mainly we design for drainage, and that's why the water goes rushing into the streams, because it's like, this water is a nuisance. Get rid of this water as quickly as we can. Make it go into the storm drains. But we don't have to do it that way. We could capture as much rainfall as possible and hold on to it. If we did that, then it would prevent both flooding and drought. Let's talk about desertification. I'm going to click out of this for just a minute. Let's talk about desertification. So desertification, one thing we need to know is deserts are not natural. Deserts are man-made. Deserts are human-caused. Deserts are not just because there's not enough rain. Deserts are because there's been a removal of ecosystems. There's been a removal of plants. So, item number 1 here, deserts are not natural. They have, because we have degraded the ecosystems, we have removed the plants. The grassland, the deserts of North America used to be grasslands. If you look at the journals of the people who were the first Europeans here, and this according to Alejandro Carrillo, my acquaintance and friend from Mexico, who read through the journals of what was his land like before the Europeans came along. There was tall grass and not just, deserts such as what you're seeing here in the picture. So deserts result from the removal of plants through deforestation, by removing the animals through, removing prairie dogs, removing beavers. And, deforestation is important because, even if the deforestation occurs, forests should exist in the hills, because when you have the rain and it falls on the forest, then the forest acts like a sponge. The sponge holds onto the water and gradually releases it into the streams. If you remove the forest, it's just the opposite. There's nothing to hold on to the water, so it goes rushing into the streams and the rivers, and you end up with a desert. Item number 3, removal of animals. A big cause of desertification is the removal of animals, removal of prairie dogs, removal of beavers. These items 7, 8, and 9, you remove the beavers because, pelts, or because they're a nuisance. Most beavers were removed by the fur trade, and beavers used to have the effect of, they would build ponds, they would build dams, the dams would cause ponds, the ponds would cause that, would hold onto the water and kind of spread the water into the environment. Plus the ponds nurture plant life, which is good for capturing the rainfall. The ponds nurture animal life. Wherever you have animals, animals tend to burrow holes or create a positive, healthy disturbance that makes that makes it such that when the rain falls, the landscape holds on to the rain. So that's beavers. Item number 8, prairie dogs. Prairie dogs dig into the ground, and they, when a prairie dog digs a hole, then the rain brings water. The rain falls into the hole, and it tends to make the landscape more moist and less flammable, and that water holds onto the landscape to promote the growth of plants and promote the growth of innumerable animals and fungi, and it makes the soil better. But as it is, prairie dogs have been removed or extirpated from 99% of their previous range. Some states even have laws that say you have to remove prairie dogs from your land on the theory that it's going to, a horse or a cow is going to step into the hole and break their leg. There's more mythology than there is truth in that little myth there. But so desertification is caused when we remove plants, we remove animals. We don't. Item number 5 here. We don't understand that animals are arteries. Animals are nutrient pumps. Whether it's salmon, whether it's bison, whether it's beavers and prairie dogs, even predators and scavengers serve to bring the nutrients back uphill. Otherwise, the nutrients, by the force of gravity, are going to follow the water downhill, and you're left with a land that does not have the nutrients to nurture the plant life, the fungi, which support the animals and which turn the landscape into a sponge. Let's go to the next slide. Next slide is lowering farm expenses. The idea here is that we could, this takes a certain amount of public policy. I'm going by the work of Gabe Brown, author of Dirt to Soil, the work of Joel Salatin, Will Harris. These are people, Vandana Shiva in India. These are people who know how farming works, and they have managed to create farms that are ecological. And they say, hey, these fertilizers are degrading the land. Fertilizers, pesticides are degrading the land. Tillage and plows, and lots of heavy equipment are degrading the land. So let's not do that. So item number 1 here is the suggestion that we lower the inputs and therefore lower the farm's expenses. According to Gabe Brown, who not only has a successful farm himself, but coaches other farmers on how to have successful farms. You save a lot of money every single year when you lower the amount of money you're putting into fertilizers and pesticides. And you might not have the highest yield, which means you might not have the highest total output, but you've lowered your expenses and thereby widened your profit margin. Item number 2 here, well, NPK. So what's the thing you're looking at? What's the image you're looking at here is NPK, nitrogen, phosphorus, and potassium. In the last 75 years, it has been a new era in farming. 75 years, we're going back to the end of World War II. Before World War II, item number 3 here says Haber-Bosch. Before World War II, Fritz Haber and Karl Bosch developed the Haber-Bosch process, which takes nitrogen out of the atmosphere, uses a lot of natural gas, energy-intensive process to take the nitrogen out of the atmosphere and fixes the nitrogen in a chemical form that plants can use. So that's the Haber-Bosch process. We now have a process. Prior to that, plants got their nitrogen, but they got it from two sources. They got it from nitrogen-fixing bacteria, and they got it from lightning. Those are, lightning has a lot of energy. Lightning is one of the few natural processes that has the power to take nitrogen out of the air and put it into form that plants can use. The air that we breathe is 78% nitrogen. So wouldn't it be great if we could take nitrogen out of the air and put it into a form that plants can use? Well, they did that through the Haber-Bosch process, but it's very energy intensive. It also results nitrogen fertilizers and phosphorus fertilizers. Ironically, according to John Kempf, item number 5 here, when you apply chemical nitrogen, then that actually lowers the amount of nitrogen in the soil that's available to the plants in the long run, because it degrades the soil. It degrades the ability of the soil to yield up nitrogen in form that plants can use. For one thing, item number 4 here, the nitrogen fertilizers end up lowering the plant exudates. Exudates is something that comes out of the roots, and the plant naturally, exudes sugars to attract bacteria and fungi. The bacteria and the fungi get their energy from the sugars that the plants exude, and in the process, they give the plants the nutrients that they need, including nitrogen. We used to do things that way. We got away from it. Getting away from it and applying lots of nitrogen fertilizers, phosphorus fertilizers, potassium fertilizers has been short-sighted. It has degraded the soil. It has polluted the water. It has lowered the amount of nutrients available in our plants. Not a good move. We can get back to getting our nitrogen and phosphorus and other nutrients from the soil, but we have to stop using NPK, nitrogen fertilizers, phosphorus, and potassium fertilizers. Next item, effective rainfall. So we're talking about dry lands and desertification, how we degrade our land and how to fix it. And when we degrade our land, one thing that happens there is that when we degrade the land, one thing that happens there is that the land ends up not being able to capture the rainfall. And so it's not about how much rain falls, it's about how much you keep. It's not the rain that comes out of the sky, it's how much goes into your soil. If you get 2 inches of rain, but 1.5 inches of it runs off, how much rain did you get? If you get 4 inches of rain and 3 of it runs off, how much rain did you get? You only got 1 inch of rain because that's how much you kept. So we need to talk about effective rainfall. The term effective rainfall comes from Alan Savory, who says, let's talk about how much rain soaks into the ground. So let's talk about that. Item number 1, it's not the rain you get, it's the rain you keep. Item number 2, Gabe Brown. Let's talk about a story that Gabe Brown tells in his book, Dirt to Soil. In 2009, now, Gabe is in North Dakota. North Dakota normally gets about 15 inches of rain for the entire year, including the precipitation that they get from snow. And the storm clouds were gathering. It was in June of 2009. Storm clouds were gathering. It was supposed to get, they were supposed to get 1 or 2 inches of rain. Ends up they got over a foot of rain. They got 13.5 inches of rain in less than a day. Most of that 13.5 inches they got in about 6 hours. Most of that 12 inches of rain came in 6 hours. Imagine getting 12 inches of rain in 6 hours. You would think there would be flooding, but it ends up not being flooding. The reason it wasn't flooding was because the rain soaked into the ground. The reason the rain soaked into the ground is that Gabe Brown had been working on his soil for years, and one of the characteristics of good soil is that it soaks into the ground. It does not run off. That's your infiltration rates. The infiltration rates relate to how much rain soaks into the ground and how fast. So it used to be that Gabe would, do an infiltration test, and you pour in an inch of rain, simulated, and it takes an hour to soak in a ½ inch. Well, that's very poor infiltration rates. Good infiltration rates are when you have, 2 or 3 inches of rain soaks into the ground in less than a minute. That's pretty good. In fact, if 2 or 3 inches soaks into the ground in less than 5 minutes, that's still pretty good. It's not great, but it's better than most. And over the course of time, Gabe improved his soil such that he could pour in a simulation, he could pour in 2 inches of rain and it would soak in less than a minute. When you're soaking in 2 inches of rain in less than a minute, those are good infiltration rates. So when Gabe gets 12 inches of rain, the first couple inches soak in less than a minute. The next couple inches soak in also. And so here you have it, more than a foot of rain in less than a day, and it all soaks into the ground. That means 2 things. 1, it's not flooding. And 2, it means there's less of a drought, because drought is not just about how much, drought is not just about how much precipitation there is. Drought is also about the impact. So one way of measuring drought is how little precipitation there is. But another way of measuring drought is the impact on green plants. If the plants are greatly impacted, then that is one way of characterizing a drought. And we're talking about, plants that are growing in the wild and plants that are crops. So if you get 13.5 inches of rain and it all soaks into the ground, then that greatly increases the period of green growth. It increases the period between precipitation events that the plants are still growing. If the plants are still growing, then you almost don't care whether you get more rain. You'd kind of like to get more rain, but you almost don't care because the plants are still growing. And so that's effective rainfall. Next item. Let's talk briefly about nitrogen-fixing bacteria. Now, why are we even talking about nitrogen-fixing bacteria? Because, your plants need nitrogen somehow, and you're going to give them nitrogen out of a bag or from your soil. So what you want to do is make it so that your soil supplies nitrogen to the plants. How does that even happen? Well, as I said a while ago, without nitrogen coming from chemical fertilizers in a bag and those chemical fertilizers degrading your soil, without that, you're left with 2 choices from nature. One is nitrogen from lightning, because lightning has a lot of energy, and then there's lightning and then there's rain, and some of that rain from a thunderstorm is going to have nitrogen in it. Might not always be able to count on that. The steadiest supply of nitrogen comes from nitrogen-fixing bacteria. And nitrogen-fixing bacteria, for example, legumes, famously, they have these little nodules, and those nodules become habitat for nitrogen-fixing bacteria. And as a result, when the legume grows and then it it dies or somehow releases some of that nitrogen into the soil, then there you have it. All plants need nitrogen, but it's not just legumes that supply nitrogen. Christine Jones, the famous and highly esteemed soil scientist from Australia, says that all plants have relationships with nitrogen fixing bacteria. And the key to that is having soil that's good enough so that the soil nurtures the nitrogen fixing bacteria. The soil has the complete food web. Your food web includes bacteria, fungi, nematodes, arthropods, bacteria, protozoa. Protozoa are your paramecium and your flagellates and your amoeba. So bacteria, protozoa, fungi, nematodes, which are the microscopic worms, and then your microarthropods, or your arthropods, which is your insects of all sizes, and your spiders, arachnids of all sizes, and there are other arthropods like centipedes, millipedes, pill bugs are all arthropods, and all of them play a role. The arthropods tend to be shredders, and when the arthropods do their shredding, they do the shredding because they have the joints, they have the claws and the mandibles strong enough to shred things and get the nutrient value out of that, and then that exposes food for fungi and bacteria and the like. So, and this whole soil food web together, working as a symphonic unit, working in synchronicity, has the ability to create habitat for the bacteria, including the nitrogen fixing bacteria, and it delivers, you thereby deliver nutrients to the plant, and thereby deliver nitrogen to the plant. So there you have it. That is a way of getting your nitrogen in a way that doesn't destroy the soil. We've been getting nitrogen from a bag for 75 years, and it destroys the soil. When you destroy the soil can no longer soak up the rainfall. When you destroy the soil no longer is habitat for that soil food web that together is the only thing capable of delivering nutrients to the plant with any consistency. So that's the nitrogen fixing bacteria. Let's see what else I have on the, let's see how much time we have. 27 minutes so far. Got plenty of time left. This is the last item. A little bit surprised that I got through all this. I was nervous. Oh, Hart, you'll never get through all that. You'll be talking tomorrow and everybody's going to tune you out. Principles of soil health. I'm going to put these up on the screen. So the principles of soil health. This is how we get all the things we're talking about. This is how we get nitrogen without getting it out of a bag, without getting it in the form of chemical fertilizers that degrade your soil. This is the principles of soil health, and I've decided to organize it in terms of the column on the left is the principles of soil health, and the column on the right is what we do instead. So first of all, the principles of soil health. This is Gabe Brown's Principles of Soil Health 1 through 5. Number 1, avoid disturbance. This means don't just disturb the soil by excessive tillage. And the other part of it is that tillage is physical disturbance, and we want to also avoid chemical disturbance. Chemical disturbance includes fertilizers and pesticides. Principle number 1 is avoid disturbance. What we do instead, we use tillage, fertilizers, and pesticides. We do just the opposite of principle number 1 of soil health. Principle number 2 is armor the soil surface. This means, organic matter on top of the soil. Wherever you don't have a plant, you want to have the soil covered. In my landscape, my home landscape here, that means wood chips. It can mean wood chips, it can mean leaves. In an agricultural context, it can mean crop residue. It can also mean if you have a cover crop and you use a crimping process or mowing and or crimping to leave that residue on top. So, something resembling a hay cutter, that kind of thing. But you leave the organic matter on the surface. You're doing this because for a couple of reasons. One is you want to not expose the soil to the sun, because the sun has heat and the sun has ultraviolet rays. You want to protect the ground from the heat and from the ultraviolet rays. And when you do that, you also do a third thing that's very important, and that is you prevent evaporation. You want the moisture to stay in the soil. You don't want it to evaporate. If the water evaporates, you want it to evaporate through the leaves of the trees, the crops, etc., which is a natural process, but it is not a natural process for to evaporate through just from bare soil. There is almost no bare soil in nature. You want to cover the soil. So what do? The column on the right, we leave the soil bare. That's what we do instead of principle number 2, armor the soil surface. Principle number 3 is build diversity. This means diversity is kind of an ecosystem concept. It's how nature works. Gabe Brown is all about how nature works. You want to treat the farm as an ecosystem. So we want to build diversity. We want to build diversity underneath the ground in the soil food web. We want to build diversity in the plants, which is mainly what we control. We control the plants, and we control what gets planted there. We also control some of the animals, but we want to build diversity. We want to build diversity in the bacteria. We want to have diversity in the fungi, the nematodes, the protozoa, the microarthropods, the arthropods, which means the insects and the spiders and the like. And what do we do instead? We plant monocultures. Monoculture, nature abhors a vacuum and nature abhors a monoculture. Nature is made up of diversity. When we plant a monoculture, what we're doing is trying to keep nature out. Nature wants in, and that's why we have to use all of these insecticides, the pesticides, which is a general term for insecticides, fungicides, herbicides. We plant monocultures and we say, nature, keep out. And so we do the opposite of this principle number 3 of soil health. Principle number 4 is living roots in the ground. In other words, no fallowing. Fallowing is when you kind of, in the old way of thinking, they're letting the land rest. Well, what we're doing is starving the land. Gabe or others say, you wouldn't starve your livestock for 6 months. So why are you starving the ground? When you don't have any plants in the ground, you're starving the ground. But instead, we want living roots in the ground. Living roots are part of a plant. There's nothing better than a plant there's nothing better for the soil than a plant. Plants take carbon out of the air, put it into the ground, and that builds up soil organic matter, soil organic carbon, and they jumpstart this soil food web. They exude carbon out of the roots. When you hear carbon, think sugar. They exude sugar from their roots. The sugar is food for the bacteria and the fungi. The bacteria and the fungi work together with the protozoa and the nematodes and the arthropods, and they deliver nutrients to the plant. So we want living roots in the ground, because contrary to popular belief, plants do not take from the soil, plants give to the soil. For the most part, on a net basis, plants give to the soil. So principle number 4 is living roots in the ground. What do? We leave the ground bare, the opposite of what we should do. Principle number 5 is integrate animals. Animals are Joel Salatin, all ecosystems have animals. Animals are a nutrient pump for the ecosystem. And, gravity goes down and nutrients flow downhill with the water. we need something to replace those nutrients. So the animals are able to travel uphill and carry nutrients uphill. When salmon swim upstream, they're taking nutrients from the ocean and carrying those nutrients upstream. And so we need to integrate animals into our landscape. If you're in a farming context, that means, let your animals, let your livestock graze your cover crops. You have cover crops on your crop fields, and the cover crops and the cash crops kind of live in the same place at different times of year. And you let the, after harvest at the right time, maybe even just once a year, you let your cattle and or your sheep graze on the crop field, and that fertilizes the crop field. We don't do that anymore. We should, we don't. So integrate animal. If you're not a farmer, you can't integrate animals into your, you don't have, if you're not a farmer, you don't have livestock. What we can at least do is let wildlife have some role to play in our home landscape. And we can also, we can respect the animal life that is in the soil, the worms, the bugs, the mole or the vole, the garter snakes, the skinks, the mammals. We should be grateful that there are still small mammals like possums and skunks and raccoons that are available to come into our landscape and do stuff. I know that, sometimes you have to protect your stuff from these animals, and sometimes the neighbors care whether there's a raccoon or a possum or a skunk in your landscape. But the skunk comes in, and the skunk eats the pill bugs. I used to have a pet skunk, and I had raised her from an orphan, and this is when I was a young teenager. I'd raised this skunk from an orphan. She had never seen her mother, forage for these pill bugs, but I lifted up a rock. There was the pill bugs, and instinctively she went eating all the pill bugs. So these animals, the birds, the small mammals, the reptiles, they provide some pest control, and they are also part of an ecosystem. So we need to integrate animals into our landscape. So that's the 5 principles of soil health. The 5 principles of soil health are how we, if we practice the 5 principles of soil health worldwide, it would be a different world. We would have, there would be a lot less flooding. There would be a lot less drought. We would have places where we could grow food. We would have a lot less water pollution and air pollution. We would be growing our food locally instead of far off. So the topic has been drylands and desertification. What can we do about it? And it's like, you might think of desertification as something that happens in Africa or India, but desertification happens here. And the more we know about it, the more we instinctively and intuitively know what the cause of it is and what the solutions are, then the more we can have a meaningful role to play in solving the problems of drought, desertification, land degradation. Alan Savory, he's famous in some circles. He's infamous in some other circles. He started off as a wildlife manager and got into livestock because he said the land needs more animals, and livestock are the way for us to put more animals on the land. So Alan Savory has lived much of his life in Africa and North America. And of course, he's traveled the world. Alan Savory says North America has some of the most rapidly desertifying land in the world, and it's because it doesn't have animals. The land needs animals. So as opposed to, there are people in our culture, in Western culture, who think that if they buy a solar panel or push for wind energy or push for, buy an electric car, something like that. Oh, I'm doing all this stuff for climate change. But if you're not doing anything about desertification, that's where the action is, preventing, if you're not doing anything about land degradation, then we need to. And this is part of a course the content I'm talking about here is part of the course that I teach called Healing Our Land and Our Climate. And we need to heal our land as a central strategy. The climate is going to keep getting worse and worse and worse if we don't heal our land. Conversely, if we do heal our land, it might not matter very much what we do about carbon dioxide. We need to address carbon dioxide, but that's a project that's going to take 100 years or more. Meanwhile, what are we going to do? We need to heal our land. So that's about all. Thank you so much for joining me. Have a nice day.